learn. So before conical pendulum, everyone know that what is simple pendulum, that we discuss first. Simple pendulum means a bob hang to a support by a string and moving to and fro like this, once to this side and once to that side. That is the simple pendulum. Now same bob is rotated in horizontal circle, then this is called as conical pendulum. So basically, so you can see in a diagram a conical pendulum. So the bob is moving in a horizontal circle, then it is called as conical pendulum. Basically, conical pendulum is a simple pendulum. So for a bob, such a motion is given, it describes a horizontal circle. Now here we have to obtain expression for period and frequency of conical pendulum. Now basically we have to consider a bob of mass m hang to a support by a string whose length is L. Now we consider that bob. Now here this is a bob. Now we have to consider forces acting on bob. So forces, first force acting on bob is a weight mg, which is in the downward direction. And the second force is tension in the string. So for tension, we are using T0 here. So this is the T0, tension in the string. So why T0 we use for tension? The reason is the title of the article is expression for the period. So for period, we are using capital T. So we cannot use T for tension. So I use T0 for tension. Now after that, so here downward force mg and along the length of the string tension. Now we have to resolve here tension into two components. So we can resolve tension into two components. This is the first component and this is second component. So this angle is theta. So this component is T cos theta. And this we can write T sin theta. So this is the second component of the tension. Now by using this diagram, we have to write equation 1 and equation 2, and that we have to process to get expression for period and frequency. You can see here component diagram. So this is a tension T0. It is resolved into T0 cos theta and T0 sin theta. And this is the radius. And this is the weight mg, you can see, which is acting in a downward direction. Now here we can say that T0, now here T0 is resolved into two components, and this component T0 cos theta is balanced by mg. So you can see here this component T0 cos theta and this is mg. They balance each other. So we get equation number 1, T0 cos theta is equal to mg. This is equation number 1. Now second here, this T0 sin theta. So you can see this component T0 sin theta. It provides centripetal force. You know that centripetal force is along radius and toward the center. If you see this diagram very carefully, this T0 sin theta is along radius and toward the center of that horizontal circular path of the bob. So here this T0 sin theta provides centripetal force. So we can write centripetal force is equal to T0 sin theta. So centripetal force is written by mv square by r, or we can use mr omega square. We can use any one formula or we can write both. So here we get equation number 2. Now after that, now here I can use this equation like this, T0 sin theta is equal to mr omega square. So this I can write as a equation 2. Now we have to process these equations. So dividing equation 2 by 1. So one side we consider here, this is equation 2, this is equation 1. So this side of equation 2 and this is side of equation 1. Now here T0 get cancelled. We get sin by cos and left hand side. Right hand side here m get cancelled. So we get sin by cos is tan. So tan theta is equal to r omega square by g we can write. Or we can continue with the sin by cos also. So if you want to write it sin by cos is tan, then you are welcome, you can write it also. Now here by using this equation, we can find out omega square. So omega square is equal to, we transfer this G to this side. So it is G is divided to this side. So this side it is multiplied, and R is multiplied to omega square. To this side it is divided. So we get omega square. Now we can write omega also by using that. So omega is equal to under root. You can see here. So I written here this G by R, then this is omega square. From figure, we can write sine theta is equal to R by L. So you know that this is the type of diagram. So this is theta. Sine of theta means opposite side, which is R, and opposite side divided by hypotenuse. Hypotenuse is the length of the string, so it is L. So this is bob is moving like this. So R by L. So we can write R is L sine theta. Hence I can write here R is equal to L sine theta. Instead of this R, we written here L sine theta. Then this sine theta and sine theta we can cancel. We get omega square is equal to G upon L cos theta. So omega, I can write it here under root G upon L cos theta. So by using that, we can write period very easily. So hence period of revolution of the bob is, period, basic formula of the period is T is equal to 2 pi by omega. Now this omega we have to substitute in this equation here. Then after substitution, we get the final expression for the period. Now T is equal to 2 pi divided by this omega we are written. Then after that, we can rearrange the term and we can write T is equal to 2 pi under root L cos theta by G. ये जो L cos theta है हमने ऊपर लिखा है, तो ये मैथमेटिकली हमने सिर्फ रीअरेंज किए टर्म यहाँ पे, बाकी कुछ नहीं है. एंड दिस इज द फाइनल एक्सप्रेशन फॉर पीरियड ऑफ कोनिकल पेंडुलम. तो यहाँ पे अगर आपने इससे पहले कभी आपने सिंपल पेंडुलम के पीरियड का फॉर्मूला देखा होगा, तो ये फॉर्मूला है T इज इक्वल टू 2 पाई अंडर रूट L बाई जी. और कोनिकल पेंडुलम के लिए क्या मिल रहा है, L cos थीटा बाई जी. तो यहाँ पे बहुत बार इन एनी एमसीक्यू द कंपैरिजन में बी आस्क्ड अबाउट द कोनिकल पेंडुलम एंड सिंपल पेंडुलम. तो कोनिकल पेंडुलम एंड सिंपल पेंडुलम का जो पीरियड है उसका कंपैरिजन करेंगे. तो सिंपल पेंडुलम के पीरियड में L है फॉर सिमिलर लेंथ फॉर पर्टिकुलर दिस एंगल. तो आप इतना याद रखिए, यहाँ पे मैक्सिमम वैल्यू ऑफ द पीरियड ऑफ द कोनिकल पेंडुलम जो आएगा ये इतना आएगा, बिकॉज cos थीटा का मैक्सिमम वैल्यू 1 होता है. तो आपको ये मिल जाएगा सिंपल पेंडुलम का पीरियड. तो यहाँ पे हमें पीरियड ऑफ कोनिकल पेंडुलम मिल गया है. सिमिलरली वी कैन ऑब्टेन द फ्रीक्वेंसी आल्सो. सो फ्रीक्वेंसी आपको मालूम है, फ्रीक्वेंसी इज द रेसिप्रोकल ऑफ द पीरियड. सो एन आई यूज फॉर फ्रीक्वेंसी इज इक्वल टू 1 अपॉन पीरियड. So n is equal to 1 upon, we are written formula for the period. Now we rearrange it and we can write the final expression for the frequency of revolution of the